Microphone check, microphone check. Okay, let's get hype. Hello, my name is Brian, and I'm here to hack on some Tiger Beetle. So, Tiger Beetle is a financial database written in Zig, and it has clients in many languages: Python, Java, JavaScript, Go, etc. And this project that we're doing on stream is making a Rust client for Tiger Beetle. And we're doing this whole thing on stream. We've been doing it for like 2 months now. And we're kind of on the verge of getting an initial PR in, not a production quality PR in, but functionally complete, I believe. And the last few streams and the next few streams are all dedicated to just kind of going through a little checklist and getting the last bit of polish done so we can present this for review. And we have a little checklist, but as I've discovered as we're going, that checklist shrinks and grows every stream. So we haven't really, feels like we haven't shipped the progress away on that checklist yet, but we're getting incrementally closer to a PR. And the last stream we did, one other thing. So this Rust client is bindings to a library called TB client written in Zig. It's a static library that currently all Tiger Beetle clients use for all languages. In the future, we may do a pure Rust client for Tiger Beetle, but right now it's just a binding. In the last stream, we worked on, I realized just yesterday that I made a big oversight in the last stream. So last time we worked on tying together the Rust build system with the Tiger Beetle Zig build system, so that when you run the Rust build, at least in tree, you also, as a prerequisite to that, the cargo build script builds Tiger Beetle in Zig to make that static library available. And I realized I made a huge oversight the last time. There's a big thing I didn't do that I will show you shortly. And I've found that that's one of the things I've found doing this streaming, is that oftentimes I kind of lose sight of the forest for the trees. Like I get zoned in on some task for the sake of moving the stream forward, and I kind of don't realize that I've forgotten a big component of that task. And that's what happened last time. So we got to go back. We got to backtrack a little and do a little more work on the build system for this Rust client. All right, let's go to the code and I'll start showing you all the mistakes that I made. You can see here on my screen, I just updated Rust. Rust 1.8.4 was released today. And so I generally keep updated. But because we updated all of our artifacts in our target directory are going to be tied to the old build of Rust, and we're never going to revisit that old build of Rust, so I'm going to do a cargo clean. Rust tends to accumulate tons and tons of build artifacts without bound. It never like cleans them up on its own. So every Rust developer has the experience of periodically going in and cleaning out 100 gigabytes of unused binary stuff. For that, I use cargo clean all. I'm not going to use it on this stream because I don't need to. But generally, every once in a while, I'll go to my like top level source directory, my development directory where all my projects are, and I'll go cargo clean all. I did that today on my laptop after I upgraded Rust, and I deleted 80 gigabytes of stuff. You can see here cargo clean all, which is it's a plugin, a crate you have to download. It doesn't come with cargo, but it goes and looks through all your cargo target directories and just finds all the target directory gunk. And here's some stuff. No, I don't want to do any of that. But let me show you the thing I screwed up. Actually, let me pull first to make sure I don't need anything here. Oh my gosh, excuse me, sorry. So last time we spent a lot of time working on the build script for this crate. And what we did was added essentially this function, which is to make sure all the dependencies that use the Zig build system are in place for the Rust build. Namely the tbclient.a static library. And if we go look at this prepare dependencies, first we check whether the build is in tree, and that's what we're focused on right now. There's another build system use case for when you're downloading the build from the crate from crates.io. But right now this assumes you have the surrounding Tiger Beetle source code available. And what this does is it names all the things that it needs, creates a local directory, the tbclient dest here, which is in this assets directory, which we added to gitignore. And then we copied all the assets into place. But the big thing I didn't do here was actually run the Zig Tiger Beetle build. Like right here, there should be a step like actually do the build. And I didn't do that. So that's the first task we have here today is, going back and actually doing the Zig build here. Excuse me, I'm a little congested today. Give me 1 second. Give me 1 second. Well, I guess it's going to be one of those days. Gross. Playing you my background music while I'm taking my moment for myself. Okay, let's see. Where are we? Let's get this going. Okay, so what we want to do here is, if we're in tree, do the build. And I'm going to say build Tiger Beetle. Manifest dir. In general, again, with build scripts, this manifest directory is kind of our anchor point within the file system. Almost everything we do in a build script is doing some kind of relative work on the file system relative to that directory. So I'll make a little function here. Just going to copy this signature. And I generally like to order my code top down, so I'm going to put this here maybe. And we're going to need to do something here. And have I already built this code? I think I jumped forward a step here. All right, actually I'm going to go, remember we upgraded our Rust toolchain. So I'm going to stash what I just did. And I'm going to go ahead and say cargo check and cargo. Oh, actually, before I do this, because we don't have the build system actually wired up correctly, I'm going to go over to the Tiger Beetle build and manually build it. So here's the Tiger Beetle source directory. And what we're doing here is we're building the C client library so the Rust client library can link to it. So I'm going to say zig build clients C. Let's just let that all fall into place. And then now we're going to say cargo check and cargo build. And in general, I always, when I sit down to work on a Rust project, I always do a cargo check, cargo build to prime the workspace with all the dependencies completely built. Okay, so it seems like it's building. So now let's unstash. And we need to actually run this build. So from the manifest directory, we need to find the probably the directory, the root directory. Let's go look at our file system here. So this is the Tiger Beetle root directory. And we probably want to be in this directory. So we're going to change directory to this directory to do the build. It might be possible to do it relatively from some other directory, but I'm always building from this directory. So we're probably going to change directory to the Tiger Beetle directory. And then our Zig compiler is in zig/zig. Tiger Beetle bundles its own Zig compiler, and it has a little script called, where is it? I think it's zig. What's in the Zig directory? Zig download.sh. So this is just a tiny little shell script that downloads the correct binary of the Zig compiler to be built, to build a Tiger Beetle. And probably we're just going to assume that somebody has already run download.sh and just assert that that Zig compiler exists. I think that's probably what we want to do. There's also the question about whether we allow people to run their own compilers, but I think essentially for the most part, everybody building Tiger Beetle is using the bundled compiler. And we won't bother to support using a custom compiler within the Rust build script. So we're going to go kind of dig out this Zig binary right here and just execute the proper command, which is going to be zig build clients C, like we just looked at. And that should be the whole thing really for this new function we have to add. So let's find our prepare dependencies function here. And we need a new directory that is going to be maybe the Tiger Beetle root directory equals, maybe we have a string here. So we're just going to do some string splatting to build the paths instead of using the path APIs. Manifester, we have to go back. Let's say our manifest directory is source clients Rust. We're going to go 1, 2, 3 directories up. And this is our root directory here. And again, this only works for is built-in tree, which we called it in this branch. If we're not in tree, we can't build the source directory. So I'm just going to say assert is build in tree here. Manifester. Seems about right. Then we have the Tiger Beetle root, and then the Zig compiler. We need the name of it. And so that's going to be let Zig compiler equals, and this is going to be platform dependent, only because of Windows. On Windows, it's going to have a .exe name. So we can say here, I think we say, we're just going to use the CFG items, compile time configuration to ask whether this binary has been built for Windows or Linux or Unix. I'm going to say if CFG, I'm going to say if not Windows. So in this case, I'm going to say Unix is the common case, so I want to put that branch first. This is the Unix branch, and this is the Windows branch. And Windows is the special case, so I'm going to check for Windows. I could also say if CFG Unix, do this, and then assume this is Windows. And as far as I know, that's true, but that might not actually be true. Like there are platforms that Rust does support that are not Unix and not Windows. So I really want to make this like we're checking for Windows. I could also do like if CFG Unix, else if CFG, this actually makes a lot of sense. Else if CFG Windows, and then have another case for like, I don't understand this case. Like, I don't know what this case is, and maybe some future developer will see that case. I'll do this actually, this makes a lot of sense to me. And we're just going to assume that on all Unixes there's no file extension for binaries, which is true as far as I know. So here the Zig compiler is going to be, and this is going to be an expression, so we need to semicolon there. For Unix, the Tiger Beetle or the Zig compiler is going to be Tiger Beetle root /zig/zig. And then on Windows, it's going to be the same thing, except that's an exe. And down here, we'll check, we'll just do an assertion whether it exists, or we'll actually make a panic with a prettier error message. This is kind of an expected case that somebody didn't run the download script that we just looked at. So maybe this compiler doesn't exist. And we'll have like a error message saying like, you know, run download.sh. So let's say if not fs exists, Zig compiler, then we're going to do something. And I think let's see how this works. I'm going to do a print line, like we'll print like a message, and then we'll panic. We could just panic with a big message. Now let's see how this shows up in how this looks in the terminal. We're going to say no. There might be some way to ask Cargo to display an error as like a warning. We can go look at the Cargo docs in a second, but let's just get this started. No Zig compiler found at, and then we'll throw the user a bone and give them a path to try to figure out what it is we're talking about here. At Zig compiler. And I'll go ahead and write this in full sentences with capitals and periods. You may need to run zig download.sh lszig ls. I'm wondering what it's called on Windows. Download.sh. It's a batch script. Oh gosh, sorry chat. I just accidentally zonked out my tmux. I have my tmux escape key mapped to Control Z because the default tmux command key, the thing you enter to enter some tmux command, is Control A, which is a very commonly used Emacs key, also in the shell sometimes. So that default tmux escape key is very inconvenient for at least me as an Emacs user. So I have it mapped to Control Z, which is something I rarely want to actually do. But then sometimes I accidentally do a double escape. I do Control Z, and that just puts tmux to sleep. Because Control Z sleeps the running process. And again, like my fingers being trained to use Emacs, I've been using this tmux escape sequence for so many years that minor inconvenience, I just deal with it. I don't want to change it from Control Z to something else. So just every once in a while I accidentally do that, and then tmux just completely disappears. Okay, so this, we said we may need to run zig.download.sh or zig download.bat. This seems fine. This is a lot of explanation for a theoretical Tiger Beetle developer who may not exist. Although for somebody trying to try out, like most Tiger Beetle developers are going to have done this already and know that this is the problem. But for somebody who's trying out the Rust bindings and maybe doesn't actually build Tiger Beetle themselves usually, they might try to build this in tree and not understand how the Tiger Beetle development setup works. And then we need a panic here. Just panic. Let's see how this looks when we do it. And this, I can leave this to do here, I think. So cargo check. And cargo check is the type checking command for Rust, which is much faster than cargo build and is kind of the core of the Rust workflow. But it also runs your build scripts. And I did something wrong here because this isn't supposed to be prepare dependencies. It's supposed to be build Tiger Beetle. See, is my text? Yeah, I was asking my text is large enough on screen, and it looks okay so far. This is called build Tiger Beetle. And this, okay, I gotta let you read the error. This fs exists. It says can't apply the bang operator because it's not a bool. That's because this returns an error, and I need to handle that error with the question mark. Here's a move of some kind. I'll let you see that. This Zig compiler, we're using that variable multiple times, and it's an owned allocated string. This fs exists, we accidentally moved it in there. So instead we gotta anchor it to the stack like that and borrow just a slice. Okay, so this failed, but not really in the way I expected it to. Oh, okay, right. So the thing we're trying to test right now is the case where the Zig compiler doesn't exist. But obviously I do have the Zig compiler. So I need to go remove zig. And now let's test this. And it says no Zig compiler found at that directory with that ugly double slash in there that I can probably resolve myself. Let's try that again. Okay, that looks a little prettier, kinda. There are APIs to remove those redundant double dot paths, but this is fine for me. You may need to run this, then panic. It would be nice if this was highlighted sort of in the way that cargo highlights errors. And I'm not going to bother doing that right now. I don't think it's worth that level of polish. There may be like something here where we can say, ask cargo to display a warning probably, and then panic and turn that warning into an error. Let's just go look at the docs. Why not? It'll be instructional. I'm not sure if this feature exists in Cargo or not. If this was not a build script, if this was a regular Rust code, we could tell the Rust compiler to emit a compile time error or warning with some kind of metadata. Well, let's just go look at the Cargo docs real quick and see what it thinks. And the Cargo docs are going to be at, I don't remember. Let's go look at the Cargo book. Let's just search for the Cargo book. Okay, remind me again what we're doing here. We're going to look and see what directives Cargo supports in build scripts. Let's go look at some directory here, or some header here about build scripts. Build scripts. Okay, I'm just looking for maybe like a reference for, I'm looking for this. Here's, things you can output to Cargo to tell it to do stuff. These are all related to linking, flags, set a CFG value, check CFGs. I've never seen this before. Register custom CFGs as expected for compile time checking of configs. I don't know what that is. It's not applicable to what we're doing right now, but it sounds interesting. And here's exactly what we were looking for. So you can, interesting. Metadata key equals value. I'm not sure what that is, but it sounds interesting. But this is the thing we're looking for. Probably going to ask Cargo to display an error. I'm glad we did this because this is the correct way to do this in a build script. Maybe better to return a result and allow the caller. Yeah, this is fatal. And then fail the build. So this emits, a properly colored message and fails the build. So yeah, I think that's what we're going to want to do. There's a question here about whether we're also then panic or whether we propagate an error back up. We could just make this return an error that contains this message and have Cargo print it. But we're printing 2 lines right now, so creating a multi-line error message in a Rust error type is kind of not possible. Anyway, let's stop yak shaving and go do the deed. All right, we're back to the code now. I'm always forgetting to switch back to the code scene, but you're seeing what I'm seeing now. And instead of doing this, we need to say, and I didn't note, Cargo error equals message. So we're going to say Cargo error equals that. And hopefully that works. Error equals that. And then we'll just panic and see how that works. We'll also try returning an error here and see what that looks like in the output. Let's see what this one looks like first. This is interesting because it did not actually print. It didn't do anything with what I printed here. Maybe I'm supposed to be printing to standard out, not standard error. Let's go look how we did our other directives up here. Where's our other directives? So here's one. And I'm immediately noticing the syntax here is different than what I wrote. Let's go pull these both into the same region so we can look at them both. So here's some working code or working Cargo directives, and here's what I did. Obviously, I should be doing println, not ePrintline, so Cargo is expecting its directives and standard out. But look at this. I copied this from the docs I just read, this double colon. But here is the previous directives I've been using. And, looking back, this is the syntax that I'm familiar with, and I've never seen this syntax. So let's just real quick go back to the browser and try to understand what's up with that. You can see right here, this definition is cargo : error, 2 colons. I'm going to back up a bit. Look at all this. 2 colons everywhere. Have they changed the syntax at some point? 2 colons. Is this an explanation right here? No. Here we go. There's the explanation. In Rust 1.77, the syntax was changed from 1 colon to 2 colons. I'm curious what the logic is for that. Maybe it's still kind of like, on the surface, that is a unnecessarily trivial change to make, right? Like maybe 2 colons would have been more desirable, but like this decision has been established for a decade. So I'm guessing there's probably some kind of like generalization here they're trying to get to by using the 2 colons, because this is like the common separator syntax for Rust modules. So maybe they're trying to come up with like a new system where this is more generalized, so it's not just cargo metadata. You can have other systems receiving directives from build scripts by saying like Clippy : something. I don't know, just speculation, but that's kind of in a vacuum, this is kind of a wild change to make because it's a little disruptive. Anyway, we figured that mystery out. So let's go back to the code. And I switch scenes, you can see my code. So this is for backwards compatibility, that's 1 colon, and I don't see any reason not to be backwards compatible here. Though, note that I have no clue what the minimum Rust version is for this crate at the moment, and eventually we'll want to do that. We'll want to like have it listed in the manifest and explicit in the docs, like, you know, we support this Rust version. And the CI will want to enforce that too. So this looks like the right syntax there. And I'm going to go back to my to-dos up here. And let's say MSRV. The MSRV stands for Minimum Supported Rust Version. It's kind of just a common concept in the Rust community, somewhat supported by tooling. If you're publishing like a library especially, but maybe a binary. If you're publishing a library, it's probably a best practice to like explicitly tell your users what version of Rust you support, like what minimum version of Rust you support, to have CI for that version of Rust on all platforms, and to encode that in the manifest. The Cargo manifest will let you say what version of Rust you support, and then Cargo will error if you try to build with the wrong version of Rust. And Rust 1.8.4 that was released today has some new features around that to make that even more pleasant experience, where it'll resolve dependencies based on the minimum supported versions of all your dependencies, so it won't upgrade dependencies anymore past the minimum supported Rust version of those dependencies. I think that's what's going on there. It's has to be turned on explicitly though right now. Anyway, that's kind of getting in the weeds, but we're going to have to address this at some point. And I'm going to go ahead and commit that to do. And again, all my commits are just kind of like temporary checkpoints. I'll clean up that history. Periodically, I go through and clean up the history, and then before we submit a PR, I'll make sure the history is sensible. Anyway, back to this error message we're establishing. Let's go ahead and do a cargo check. See what this looks like. And again, Cargo did not do anything interesting here. And I'm wondering if that's because we panicked, and so it decided it maybe didn't know whether it should use that. Maybe if we return an error, it'll use this error more. Maybe if we turn an error, it'll use this error. So let's go ahead and try that and say return anyhow, error of anyhow. No Zig compiler found. obviously we can't have this redundant information in our error message, but let's just see what this looks like. We're just trying to understand exactly how the cargo's error capturing behavior behaves here. Anyhow is a macro we need to import. Anyhow is a library in Rust for easy error handling. Yeah, I'm a little miffed here. I don't quite understand why it's not doing anything useful here. Like, I'm expecting these two things. Did I not switch them to, yeah, these are printing to standard out. I'm expecting Cargo to capture these and print these more like this error message. This does not seem correct. What if we call this a warning? Does it do anything more interesting then? So there, it did capture those. What do I not understand? Maybe Cargo requires an error to exit successfully? We're just doing some exploratory programming here to understand how Cargo treats these error directives. Yeah, as far as I can tell, this is the correct thing to emit. Let's try something drastic. Let's say stood process exit 0. So successful process termination, but we're telling Cargo now it wasn't actually successful. Let's see if that's what Cargo's expecting here. No. Nope. Cargo returned success. Why doesn't this work? Let's really quickly go back to the browser. Oh, interesting. I didn't notice this when we were looking at this. This is a brand new feature introduced today in today's compiler, whereas warning is old. So we actually, I'm guessing maybe the new compiler doesn't even bother to support the single colon syntax for this directive because it doesn't require backwards compatibility here. So we can test that. I'm guessing that if we do a cargo colon error, the old syntax for this type of feature, it will work. But then also we're not going to be able to use this because I don't want to force people to use this new of a compiler right now. So let's go test that hypothesis. Back to the code. And we're yak shaving so much. But I bet if we put 2 colons here, and then here we can panic. This will probably do the thing we've been trying to get it to do. There you go. Okay. So that's the thing. Oh, I made one of them wrong and one of them right. 2 colons. So there you can see the cargo is emitting that error and we exited without succeeding. But we're not going to use this feature. We're going to use the old, this is what we used to do for this. Whoa. I just hit the wrong button and full screen this whole terminal. Give me a second, chat. I'm in trouble. Oh, okay, F11. This is what we used to do in this situation. Say, emit a warning, and then fail hard. Let's try and see what that looks like. Yeah, good enough. Good enough. Good enough. Kind of ugly. I'm kind of thinking about right now whether I'm going to have to explain this, the why this is the way it is in the PR review. But I kind of want us to move on. We're not making a lot of progress right now. So if it doesn't exist, we got to go to run download.sh. So let's say git status and git diff, and just checkpoint this work here. And also we don't need that anyhow anymore because we didn't use anyhow. And cargo check. Okay, that's looking good. Just checkpoint that work. And then let's actually run the build. And to do that, I'm going to need my Tiger Beetle or my Zig back. So I'm going to run Zig download. That should give me a Zig. I'll let you see what it does. And I'll take a drink. I'll let you see what it does, and I'll take a drink. Sorry, just messing with my audio setup while I let that build. Just goofing around over here. I used to have this idea that I would play a little music while coding on stream. But I think it hasn't really made a lot of sense to do that. Okay. Zig is installed. Now let's run it. So we're going to need the command API for this. And to do that, we're going to say let command, that's probably going to be mutable, equals std process command new. And this is the path to the binary, which is Zig compiler. And if you recall, what we have to run to build this is zig. That is our build command. Zig build clients :C. So in our code, we're going to say command.args is build clients :C. That should be the whole thing. Let's say args dot. Now this is where we have to remember which way we want to execute the process, because there's all types of different configurations that are around, whether you need to let standard out and standard error just print directly to the terminal, or you need to capture them or whatever. And I always have to go cross-reference the docs when using the command API. And this is an API I use with some frequency. Still, I pretty much always have to read the docs for it. There's another library called Xshell, written by MatClad. And when I do a lot of command execution, like executing other processes, I'll often use that because it's somewhat more ergonomic than the command builder in Rust. But here we're only going to run one thing, and I don't want to pull in a dependency for that. So here we say args output. I think output is capturing, and I don't want to capture anything. I just want to run our command and let the terminal do what it does. So probably status. I think this just runs, waits for completion, and then looks at the status without doing anything with the output streams. All right, let's go back to the code. Remember status. And I think I remember what exit status is all about. Let's go to the code. Let's say let res equals result equals art.status. And that'll be probably a possible error there. Then we can say if not res.okay, might be is okay. Then we can say panic zig build failed. That is probably sufficient for what we need. And let's see if that works. Args status. Args is not found here. Oh, it's called command status. Okay, method not found. It's probably success, actually. Okay has a very strong meaning in Rust. It's associated with the result API. So if you see the word okay, it is usually around error results. And this is not an error result. This is just the process success or failure. All right, that works. And so here we built Zig. No, we did not build Zig. We built Tiger Beetle with Zig. And it seems to work, but let's verify that manually by going over here to just delete the Tiger Beetle binary right there. And now run cargo check again. And if we go look at that Tiger Beetle binary, we'll probably, What we are doing here is we are building the library, tbclient library, and not the Tiger Beetle binary. So let's go ahead and delete not the Tiger Beetle binary, but the source client C lib directory. This is where the static libraries exist, or where they're output to. Let's remove all that. And now let's try the build again. And you can see they're all back again. Great. But speaking of building that Tiger Beetle binary, we want to do that too, because one of the things we're going to do probably today is make a test suite. And that test suite's going to have to run the Tiger Beetle server. So let's do not just this, but 2 different builds. And what I want to do is parameterize this, because we're going to run it twice, basically. And I'm going to say, what I want to do is parameterize this argument to the build system. And let's go find the build command we're going to need. Zig build. But I want to say zig build something to build that Tiger Beetle binary. So we're going to figure out what that something is. And I'm going to delete, well, let's real quick, make sure that Tiger Beetle binary exists. Now let's remove it again. And I'm guessing I can write Tiger Beetle here. No. Let's list all of our possible steps here. Build. Run. Oh, is there not a word I can put there? Oh, install seems to be the one. It is the default. So if we run build install, then we get a Tiger Beetle binary. And yep. So what I'm going to do here is I'm going to say let build target equals clients C install. And then say for build targets, build target in build target. I want to put a comment here on why we're also building this. Build the CTB client library. Build Tiger Beetle binary for testing. And I'm curious what'll happen when we run cargo format on this. I'm guessing it'll leave it alone because we've got these line comments here. And this is just going to be format. build target. And that looks correct to me, so let's go try it again. This is pluralized. I need to have some kind of plan for like what to chit chat about when the build is running, because kind of my internal flow just stops for those few seconds while we're building. I have no um, stream of conscious monologue to emit at that point. It's just like bleh, just waiting. But for the purpose of streaming, like every time I just run the build and I'm waiting for that linker to finish, I should keep talking. I don't have mold installed on this machine, I think. I don't think. Yeah, mold is a slightly faster linker, so it can make the build a little faster. But this looks like it works. Real quick, let's delete Tiger Beetle one more time and just make sure that it comes back after we run the Rust build. Yeah, there it is. This seems all correct. Let's go over to, let's step back real quick and think. Let's just not plow forward. What did we intend to do here was make sure that library was built by the Rust script, and this looks right. Okay, so I think we've done it. Let's check that to-do off. So we finally finished 1 hour, and we finished fixing what we failed to do 3 days ago, last stream. And let's just, again, take a breather and think. We're looking at our to-do list here. This review Go bindings, we did this already last stream. These are kind of the two big ones, the test harness and the error handling. I think we want to make some progress on the test harness today. Okay, so the test harness, let's just clear our heads a bit. And think a little bit about what we actually want to accomplish here, because the test harness, I've been putting it off because it's a fairly chunky piece of code to write. And every time you need to do like an integration test where it's not just letting the Rust unit test runner do its thing, it often requires a little bit of thought and more interaction with the other processes, and it's always just a little bit grungy to set up, and I never quite look forward to writing a big custom test harness. But it's a pretty common Rust topic and something we got to do. So if we think about how we're going to test this, right now we have no tests. We have a little smoke test that we run manually that is not a useful test for CI. But probably what we need is some kind of little mini framework for running the Tiger Beetle server at a known address that hopefully doesn't clash with any other addresses in use on the machine. And then we run some sequence of commands using our API, just a regular old sequence of like a test, just a regular unit test against that server, and then shut down that server. And every time we do this, we need a fresh database in order for the test to be reproducible. And that's going to present us a pretty big problem because the initial database size in Tiger Beetle is gigabytes. Real quick, I can show you. I'm going to go to the code. Hey, Brongalus. I had a pretty chill New Year's. I hope you did too. I did not go anywhere by choice. I was happy about that. People always ask me, like, what are you doing for the holidays? And it makes me feel like a little bit self-conscious that I'm not doing anything for the holidays, but that is my desire to not do anything. In fact, I got a lot of work on the stream done over the holidays. I don't Yeah, actually, I'm in the US, and we have the big ball drop in New York on New Year's, which is very uninteresting, and it gets, like, more uninteresting every year, but, we actually forgot it was happening. It's kinda like a ritual to go watch the ball drop on TV, but I'm sure it kinda matters less and less in the internet age, like, who cares about that stuff anymore? But we actually, forgot it was happening because 'cause we're not in the same time zone as New York. And so it was like an hour later, and we were like, "Uh-oh, should we go watch the thing?" And we watched it. And the the New Year's Eve ball, it's so stupid and boring. Like, the broadcast that we looked at, like, they had this big sphere, and it goes like this, 10, 9, 8, 7, 6, 4, 3, 2, 1, and then it cuts away to something else, and it's like, "Why is this such a celebrated ritual?" Like, the camera angle was probably bad, but it was like dropped on the screen, it was like 2 inches, slowly moved down 2 inches, cut away. That was the whole thing. So, pretty underwhelming. That was my New Year's, so thank you for asking. So, today what we're doing though is creating a test harness. Yeah, so I got a bit distracted there. So the test harness, it's gonna have to like create a fresh database for every test, and I remember I was gonna show you the database size. Just let's see how big these databases are. So 1.1 gig is around the size of a fresh database. And just creating it takes some time. So probably we'll start by just, literally when you start up the test harness, like every single test, it'll create a temporary directory somewhere and for that one unit test, and then run, the Tiger Beetle command to format a new database, and we'll kind of see how it goes. But I'm guessing it's going to be unbearably slow for development. And so we'll probably want to add some kind of like test to database caching where we format a new database once, and then every time we run a test, we copy it around in order to make the testing much faster. But this giant blob of nothing, because it contains almost nothing to start with, it's kind of going to be a big pain for us when it comes to testing. But this is also, interesting type of rusty, testy thing. Great for instruction on a stream. You have to do this kind of thing all the time when you're doing integration testing. Just figure out, like, how do I create a framework to test this thing in a reliable way that people can maintain for years and years and years. There's a question in chat about using containers for tests. Like, we could create a container, and that container could contain this database. And then every time we start up that container, it'll just, use its overlay systems to create a fresh environment that has that same old database in the container. And I would say that in general, if I am a casual developer and I see that building some open source project requires doing anything with Docker, I immediately bounce. I know there are a lot of people that are very fluent in Docker that just feels very natural to. But as soon as I need to go outside of like the stock build system for my language, um, I it's immediately a big barrier to contribution for me. Like, if it's something that I have to do for work, then of course I will learn the workflows. But as a casual contributor, they're not going to run that test. So I avoid that at all costs, really. In fact, I don't think I've ever. That's not entirely true. I mean, I've used Docker for some test cases that are very, very specific, and where we can kind of isolate that test suite from the user or the developer contributor experience. But for something I'm expecting, non-paid people to come do before they submit a PR, I'm not going to have Docker involved. I do recognize that, like, if you're making a kind of a cloud product for a business, then you're going to do what's best for the business. But that's not what we're doing here. We're kind of creating an open source product that we expect casual people to do drive-by contributions to. So we're not going to have that kind of container-based isolation, which is a negative. Containers are really nice when you really want to make sure that your entire environment is completely reproducible. And we're not going to have a reproducible environment for these tests. So we have to be very careful about how we structure things. Like we need our temporary directories. We don't want our pollution between test directories and things like that. And then there's environment variables that might change how cargo behaves in ways that we don't expect. But it's a trade-off here, and the not requiring people to touch Docker is kind of a big factor for me. Thanks for the question. Great question. Yeah, as long as Docker has been around so much, and it's kind of like a standard part of people's toolbox. But and I've used it many, many times. But it just always feels like a little one step too far when it comes to the developer experience. Something about it is just, it's for me at least, it's not just a natural part of my workflow. I don't just expect to be running Docker containers for every little purpose. I know a lot of like cloud developers and backend developers are probably very comfortable just running Docker all the time. But it's not me. Okay. And once again, I forgot what I'm doing. All right, we're still talking about the kind of issues here around this test harness. But I think we get the picture. We need to do a fairly elaborate harness here that does its best to kind of create a new environment without using a container for every single test. And now we got to decide where we're going to put this test. And in Rust, there's a number of ways to structure tests. We're not going to put it directly in the crate because this is a pretty complicated test suite. And I feel like it should kind of not be looking directly into the internals of this crate. This is an integration test, not a unit test. So I'm going to put it in the standard kind of Rust location for integration tests, which is a directory called either test or tests. I don't remember, but I'm going to make a directory called tests and see if this works. And there's a bunch of like default ways you can structure code you put in this test directory, and I'm always forgetting what all the defaults are. It's supposed to, Cargo has all these like defaults because it's supposed to make things easier, but then like I actually don't ever remember what the format of this test directory is. Like we can definitely just like put a file in here and call it anything we want, and it'll be picked up as a test. But then we also have some support code that we're going to need to write that is not itself a test. And I'm not exactly sure how to structure that. But let's go ahead and just kind of write some stuff and see what happens. So I'm going to say tests.rs. I don't think we're probably going to have two integration test suites, so we'll just make tests.rs the root of this integration test. And for now, I'm just going to put all the code in here, but eventually we're going to have to split it out because we're going to have enough support code for the testing framework and then enough tests that it's not all going to want to live in one file. But for now, we're just going to do it all in one place. And I'm just going to write a test here, see if this all works. Call it let's fail. And then say @panic. That's the Zig syntax. That's the Rust syntax with a bang. And we'll say cargo test and just see what happens. When cargo actually picks up tests from many different places, so that we might see several different sets of tests running here, and most of them will be empty. And that'll create a lot of visual noise like, well, let's just see what it does. So probably what I'm going to do is go disable some of Cargo's test suite so it just doesn't do things like run doc tests or run the unit tests. So here it tried to run 3 test suites. The first one is these are the unit tests inside the Rust crate, which we have none of. And I don't really expect us to have any unit tests, but we might at some point. These are the doc tests. No, this is, what is this? Source lib, source main. Oh, okay. This main file here is our our little test binary that's not going to survive. So this is going to be deleted at some point, but this is kind of picking out unit tests from our binary. A Rust crate can contain both library and binaries. And this is running the doc tests for that library. And you can see here it did not pick up our test file. I'm guessing the reason here is probably because this test directory I created, I guessed wrong, and it should be tests. So let's just see if that's true. I'm going to move test to tests. And we'll run these again and just see if it picks up that new file as a, yeah, okay. So the default location for test is the tests directory, not test. But there, it picked up our tests. And I'm kind of thinking about whether I want to drop any of these test suites or not. And I kind of don't think I will. These doc tests, we will definitely have doc tests at some point. And this main file will just go away at some point. So I'm probably just going to leave it the way it is, but maybe when I run these tests, I'm going to say test. The flag here says which test to run. And I believe I just named that file test. No, tests, probably. So the word test here is used a lot of semantic saturation there, I think is what it's called. But you can see here, now it didn't print all those test suites, just running the one test suite we're working on. And so we have a little test here, but this is not sufficient to do anything yet. So we're going to create a type called, and I'm going to put this up at the very top of this file. All this test harness stuff is going to end up its own file eventually, but I'm going to call this harness. I don't like the word harness. I just don't like the word harness, but it's common for custom test suites to have to be a test harness. So I'm going to call this harness. And then, oh, this file is no longer in this directory. My buffer is incorrect here. Open this up and call this struct test harness. And then I'm going to give it an impl. I haven't really thought this through ahead of time, so I don't exactly have a plan here, chat. But what I want to do, probably don't need to create a constructor for this. We are going to need a directory. Let's think about what we need in order to run a test. We're going to need to find the Tiger Beetle binary, and we're going to need a temporary directory to work in. And we're going to need to be able to run the Tiger Beetle binary. And we're going to need to format you run the binary with a known port number. And run the server listening on a known port number so that our APIs can connect to it. All right, let's just write some of that stuff down. And let's say Tiger Beetle bin, and we'll just call this a string. This could also be a path buff, but we'll just find it by string. And then we also need a work directory, a temporary work directory. And we're going to need a crate for this. Yeah. All right, let's go to let's go back to the docs and find the crate we need. I mean, I think I already know what crate we need, but we're going to need to look at the API docs to understand how to use it, or to remember how to use it. So let's go to docs.rs/temp file. I believe there are several crates for temporary files, and some of them are bit rotted and very old, but this one has been released in doesn't say right there. Really? Let's go look at this. Huh. This really doesn't say the date that it was released. Well, we can go to crates.io and that will show us when it was last updated 7 days ago. So this is a current crate. And we're going to need not a temp file, but a whole directory. Is that true? we really only need a database, but I think we are probably going to want a tempter so we can tell Tiger Beetle to just go work in that tempter. And we might need to do other file stuff too. So we'll make a temp directory. And this tempter function, I know that this will use, some system specific temp directory location, but for, development stuff, I don't like to just punt my temp files to something like /temp or wherever they go on Unix. I like to have them somewhere where I can go poke at them and look at them. So I'll put them in like a directory right under a current working directory and then just git ignore that directory. So we know we need this temp file crate. So in cargo add, we will say cargo add temp file. And we need this to be a dev dependency for testing, not a regular dependency. And that will just add it directly to our manifest. So up here we can say use temp file temp dir. And I need to be on the code screen. Sorry about that, y'all. Now you can see my code again. And here we'll say, I'm going to call it workdir, and it's going to be a tempter. And we are going to need a constructor because this test harness is going to want to construct that work directory, a temporary directory. So I'm going to have a function here for constructing this. And this is going to need to return potentially an error. So we're going to use anyhow result, and I usually rename result to any result here because this is such a common type to use in Rust code, especially the Rust code I write, that I want to see this exactly what result this is. In Rust, we're often renaming result types for specific types of errors. And so if you see the word result in Rust code, you don't necessarily know what kind of result it is. And so this is, in my code, you see a lot of any results everywhere, and it tells you immediately this is an anyhow result, a result of anyhow. So it's going to be an any result of a test harness. And I'm just curious whether this all still builds, so let's go run our thing again, and got to go download that temp file directory. All right, everything still builds. And now we need to think a little bit about where this workdir is going to live. And it's going to live in, I'm thinking we might put it in a subdirectory of the manifest directory. Because we could be running this test suite. I'm thinking I don't want to make it a subdirectory of the current working directory, because we could run this test suite from any number of places. And then it would kind of just show up either at like the top level Tiger Beetle source directory, or if I run it from where I am right here in this terminal, it would be in this Rust directory. So I think I'm going to instead tell it explicitly that this directory where the manifest lives is kind of the root of where our temp directory is going to be. So again, similar to in the build script, we got to go find that manifest directory. And the way you do it in a test is different than you do it in a build script. Again, Cargo is going to communicate that to us, but I don't remember how offhand. So we're going to go to the back to the Cargo book. And here's the build script page, which is not the page we need. We need probably this test page. And somewhere in here, no, there's nothing on this page. We'll go look for environment variables. So this page, this is such an important page in the Rust world that I tend to have this hyperlinked and bookmarked from various places because I read this page a lot. This is how Cargo communicates with the world. So here's environment variables that are inputs to cargo. This is environment variables for that it sets for regular old crates. No, this is more inputs to cargo. There are also dual configuration values. These can be set in files or environment variables. This is the environment variables that sets for normal crates, which is not what we're working on. We're working on a test crate. This is the build scripts. This is what we were working on before. And there's not a section in here. I was expecting there to be a header like, environment variables cargo sets for tests. Doesn't seem to be true. So maybe it is this section up here. Cargo manifester. That's going to be what we're looking for. The directory or the path. So cargo manifester is what we're going to use again to get that our initial root directory for the work we do. Let's just go back to the code and get that part done. And we'll say let manifest dir equals, I'll import stud inv. It's going to be inv var. Is this true? Environment variable set here? Or is this going to be a CFG environment? Some environment variables are like runtime environment variables, and some are build time. And this invar I'm about to type is for getting a runtime environment variable, but you can also run something like inv bang, and that will pull something out at build time, which I'm feeling like this might be. I'm actually a little, oh yeah, let's go look at the docs. I'll show you exactly what I'm confused about. The docs even tell us right here. These are set at compile time. So if you want to, you can embed the cargo manifest compile time information directly into your binary so that it can be used at runtime. And that's what we're going to do. So we say inv bang cargo manifest dir, and this returns an option, I think. And we're just going to say expect manifest dir, because this should always be set. I think this returns an option. We'll see what the compiler says when we get there. And then what we have to do with manifest dir then is construct our temporary directory underneath that, and underneath a directory of a directory. So we're going to say work dir. This is going to be like a directory for storing our temporary directories. I'm going to say format manifest dir. I'm going to call it work, but I'm not sure if that's what we want. And then this will have to be get ignored. And then under this directory, each time we instantiate a test harness, we're going to create some unique ID there. And then I'm thinking also, like, when we create this work directory, we're going to have to give it a name that we can go find as a developer. So maybe we need to pass in the name of the temp directory here, but I'm not so sure I want to do that. Anyway, the next thing we need to do is just, check this and make sure it still type checks. Looks good. This is not type checking our test though. Let's go in cargo test. And that doesn't type check. I wonder if we can say cargo check test to type check the test. Indeed we can. And it says method not found on stir because in bang doesn't actually return an option. It just returns a string that might be blank. It's kind of an awkward API. Feels like if that was redesigned today, it would be an option, not just an empty string. Okay, now let's go back to documentation. Oh, that's not documentation. That's my audio setup. Documentation is over here. So we're done with the cargo environment variables probably, but temp file, we need to understand how tempdir works. And I'm not going to bother that summary, but we can say new in to tell it we want a directory in another directory. And then once we have that directory, we might want to say with prefix or with suffix. And this prefix we could use to give it like the name of the test that we're testing. And then it would generate like a randomly unique suffix for that directory. So we'll probably do like with prefix in, and then give it a test specific prefix and that work directory. And then from there, we can get the path directly out of the tempdir. Let's do that. Remember, with suffix in, with prefix in. That's what we want to do. With prefix in. So over here, we'll say let tempdir. Oh, interesting. I gave two different variables the name workdir. I'll call this tempdir equals tempdir with prefix in. And we'll go ahead and give this test harness a name and call this, the prefix is the name. And then it's created in workdir. And probably that returns error, possibly. And then after this, we are not done yet because we haven't named Tiger Beetle bin. So we have manifestdir here. And let Tiger Beetle bin equals format manifestdir. And then we have to traverse up, up, up. Here's our path for the manifest. 1, 2, 3 layers up. And then Tiger Beetle is, it's not a din, it's a bin. And then of course this is platform dependent. So on Unix, it's going to be Tiger Beetle. So we'll say if, and you use the same formulation that we used previously. If not CFG Windows, do it that way. Else if CFG, actually let's go to the build script again and remember how we wrote this before. If CFG Unix, if CFG Windows, okay. So it's going to be if CFG Unix, CFG, and that's a macro. Otherwise, if it's Windows, we do something. Otherwise, we're confused. .exe. And now we can just build our test harness and say, OK of test harness. Tiger Beetle bin tempdir. And I think that is all sufficient. And then this dir will just be deleted as soon as test harness is dropped. One thing we should probably also do here is make sure this workdir exists. I don't know if tempdir will recursively create that workdir, but I kind of feel like it's appropriate for us to say fs, we'll import fs, create dir all workdir. That seems okay. And let's go run that. And it's doing stuff. What is it doing? Oh, I just said cargo run. I'm not running the test. Cargo test. There we go. Okay, so it all builds. And that's probably enough to construct the test harness. And so then in the test, I'm going to call this test smoke. typically like the first test when you're writing a test to figure out how to write the test. It's the smoke test. Create something that basically works without caring exactly what it's doing. Let's say let harness. I hate the word harness. Test harness. Whatever. Harness equals test harness new smoke. And again, we're only using this smoke for the test prefix. It'll generate some random numbers after that. So if we accidentally duplicate this name in other tests, it won't be too big of a deal. And let's run that. And I'm thinking like I put these directories in a place where I can find them, specifically so that I can introspect them during development. But this is always going to clean up those test directories. So we won't actually be able to see those test directories unless we do something like hard abort the process right here, so this destructor can't run. Anyway, there's a build error here, so let's fix this build error. What this is saying is that I'm trying to do error handling here, but the test doesn't return any errors, so it can't use the question mark operator. And it's telling me something close to what I'm going to write there, but not really. That's an interesting suggestion. That'll work, but very verbose. So our tests are all going to return any result of nothing, and this should build. Doesn't pass though because we're panicking. All right, so now we have a test harness that creates a directory to work in. And let's go ahead and add a method to, I'm going to do this incrementally in several methods on test harness, but eventually it'll probably all be folded into one method to just do all the setup. Let's add a method to format the database. So we'll call this function prepare database. I'm not going to call it format because I'm already expecting that we're not going to want to reformat an entire database every single test. It's going to take self. And it could fail. And when we prepare a database, that means we're going to run Tiger Beetle format. So let's say let command is, we probably going to use command enough here that I think we'll import it. Use std process command. And we'll say command new. We got to find that Tiger Beetle bin, which we have it there. It's self Tiger Beetle bin. Self dot Tiger Beetle bin. And we're going to say command dot args format. And we're going to need to go look up exactly what the args are going to be. This command is a builder type, or it implements a builder pattern in Rust. So oftentimes you'll see people do something like command new .args .status or something like that. But these commands have problems with lifetimes and these big method chains in situations that I don't recall offhand, but I usually assign my command to a stack variable just so it's anchored in the stack so I don't run into any issues. But yeah, the builder pattern in Rust is a little frustrating. There's no one way to implement a builder pattern in Rust that is entirely satisfactory because of passing temporary reference lifetimes through a chain of methods. You end up with those lifetimes not being anchored to the stack, and sometimes they get freed too early, basically. To we need to go figure out what the arguments to format are. So we're going to say zig build run, which is the same as just running Tiger Beetle, but it builds it first. And then we're going to say format, and we're going to get it to tell us what to do. And here we are just chilling while LLVM does its thing. This is probably not LLVM, it's probably actually doing a linking there. But the Zig message said it was doing an LLVM thing. Replica count is going to be 1 for our test database. And then we need to give it a name. And I think there's one more. Also got to say replica equals 0 maybe. Path already exists. I can delete that path. Okay. And also we need to tell it which cluster we're using. It's not specified by default, but by default, Tiger Beetle will pick a random number for the cluster. And for testing, we need a specified number. So this is what we're going to do. I'm just going to copy it. And drop it in here. So we're doing format replica count equals 1 replica. Oh, I gotta be honest, Chad, I'm kind of running out of steam, and it's pretty difficult to keep the energy up. Like, we're at a point where I just want to like power through all this work and get the PR done. It's pretty hard to keep the energy up and, you know, focus on the actual work. All right, here's our arguments. Our command. Yeah, you can hear me. I'm just so sleepy. And then we can say command.status. And this is going to run and let everything print to normal, standard out, standard error, and tell us whether it succeeded or not. And probably we're going to want to name the path to this. This is not sufficient here for this command. We also need to put it into the right directory and or give this a full path to the database. So this Tiger Beetle bin is going to be an absolute path. And I think what we should do is say command dot change directory. I don't remember exactly how do you switch the working directory here. Let's go to the docs. Let's go to the docs. And std.rs command. One of the things here is going to set the working directory. That it's called current dir. Current dir is going to be self.tempdir.path. Just like that. And then within that path, we have a known name for the database. So every time we run a command here, we will just switch into this directory and reuse that static name of the database. So I think this is correct, but I'm not really sure. Again, I'm kind of losing steam. So we need to say harness prepare database. And I'm kind of wondering if there's a way we can tell this tempdir to not do its cleanup, so we can go interrogate what the actual directory looks like here and make sure this is doing the thing we think it's doing. So let's go back to the docs over there again and see if there's a way to tell Tempter not to do its cleanup. Docs.rs temp file, Tempter, and you can say into path. So this will probably do it right here. Close will probably do cleanup, but then into path will probably just say, yeah, forget about it. Removes the temp directory without deleting the directory in the file system. So we can just convert the directory into a path and forget about it. Let's try doing that. So in our test, we can say harness.tempter.intoPath. It's kind of an awkward way to accomplish that because it doesn't really directly read like what we are attempting to do, but let's try it. Okay, so got a little more to do in the prepared database. This returns a result type. So we've got to put an OK down here. And again, we're going to run this test and just look at what is inside of our work directory, because now we should have a directory here called work, and we expect it to be a temporary directory there. And you can see it's called smoke with some random stuff after it. Makes me think we want to put a dash there probably. And if we look inside that, we should see a Tiger Beetle database, and it should be big. There we go. So now we can freely just blow away work whenever we want. Let's try that one more time and just see how long it takes to build that test database. Two seconds. Not great, but not as bad as I thought. We can probably live. We can probably just live with that, actually. If we need to, though, we can kind of have like a global one-time initialization where it creates this one Tiger Beetle database and then copies it around every time you create a new test harness. But for now, this should be good enough. And again, I can just blow away that directory. Though before I do that, let's add it to gitignore. So let's create that directory again and say git status. And you can see that, you can see that Git thinks there's an unchecked in work directory, but that's not true. That's surprising. Why is that the case? Let's see if we have a .gitignore file here. Target, assets. We haven't explicitly told it to ignore that. Maybe the main Tiger Beetle doesn't even have a .gitignore. Huh. Why is that work directory being ignored? Smoke. I wonder if there's a way to ask Git what it's ignoring. Anyway, it doesn't seem to be a issue right now. Maybe clients has a gitignore. It's ignoring shared libraries on Unix. Let's see if source. No. I have a gitignore. Hold on. No gitignore in source. There is a gitignore in Tiger. There is a gitignore in Tiger Beetle. Ah, okay. So Tiger Beetle does have a gitignore file, and it's ignoring standard database naming scheme. Okay, that's why we're not seeing Git want to pick up that work directory, which is fine. We don't want it to look at that work directory. But it's about time to checkpoint our work. And we no longer need to keep those temporary directories around. So now we have a database, and now we need to serve that database. I'm going to say serve. Yeah, I'm going to say serve here. And this is going to return, how should we do this? probably we're going to want to serve the database. Then while the database is running, run a bunch of stuff, and then cleanly shut down the server. So this is probably going to return a process handle of some kind. And I don't remember what that's called, but it's going to be any result of handle. And so what we'll end up doing in our test is we'll say let server equals harness.serve. And then as long as this stays in scope, the server will be running. And then we'll run a bunch of test code down here. The server will get destroyed. That seems about right. One of the things we're going to have to consider is to kill the server, we got to literally send it a kill signal or some kind of signal. I don't actually know how to do that offhand. But let's go get the server running at least. And to do that, we're going to need to go look at our docs again. And this is in the standard library. Back to our command type. So when we're not going to do the status anymore. We're going to run the program and then hold on to it, which looks like it's probably spawn. This child is a handle, so that's probably what we're going to return in that function. We're going to say spawn the server and return a handle to the child. Hey, Cargo Moon, thanks for coming in and wishing me a good stream. I really appreciate that. That actually does help a lot. Right now we are building a test harness for this Rust client bindings, and it is a bit of a slog as expected, but this is all pretty typical Rust testing stuff so far. So we're going to spawn this server and just hold on to this child handle. Let's go ahead and look at child and see what we can do with it. So we have handles to the streams from that child. Optionally, they might just be going to the terminal as well. And then we probably have some methods. Okay, great. We have a kill method on that child. That's exactly what we need in order to kill the server. So remember, we're going to return a process child, and we're going to run a kill on that child. Let's go back to our code. Go back to the code. And this is going to be child, and we'll import that. Not child, child. And actually, this might not just be a child because we know we're always going to want to kill that server. So we probably need to wrap this child in another type that has a drop implementation that calls kill on it. One thing we could also do is not do this kind of resource-based management here, resource management. Sorry. Not use the kind of scope-based resource management and just have test harness hold on to a server process, something like that, and then just call a method on test harness. It's like serve to start serve and then kill to stop serve. Or test harness itself could have a drop that if this child exists, kill the server. And that actually kind of might be a more ergonomic way to do it in this case. Like, do we really want our test cases all having to hold on to this server correctly? We might just say like harness.serve and be done with it. And then let harness go out of scope. That might be the way to do it, actually. Are we ever going to want to, serve, then shut down the database, then serve again? I kind of don't think so. So I'm actually thinking, let's do it that way. I wonder how that will go in review. Probably no one's going to care. Test code doesn't get looked at nearly doesn't get scrutinized the way production code does. So here's the server. And then when we create the test harness, that'll just be none. And then when we say serve, we're still going to return a result, but we're not going to do anything else. And then we'll implement drop for test harness. I'm implementing the kill stuff because that's easier to me than implementing the serve. So I'm kind of going in the wrong order here. I'll say drop, and that takes a self. And then I'm going to take the child out of this server before killing this child. For reasons that I will try to explain, kind of nebulous reasons, but I'm going to say child equals self.server.take, and this will be an option of child, but it'll take the server. If there is a running server in the test harness, it will leave a none in its place, and now the stack will own that child process handle. And really we can say match right here. And sum child equals, and then none is just going to do nothing. We can really say if let in this case. Sometimes I like match, sometimes I like if let. I was just thinking about this the other day, and I really like match because match puts you in like the mindset of enumerating all the cases. So we weren't going to do anything in this none case, and in this case I don't think it really matters much, that enumeration mindset. We're just going to say like we're going to be in a more procedural mindset, like if there's a child, do something. But especially if you have like, a lot of cases, or you're doing a lot of kind of like table-based development, where you're doing a lot of matches, it can be nice to just be like, yeah, maybe I'm only going to do something in one case, but still I want to enumerate all the other cases to make it explicit. Because if you enumerate all the cases, of course, it's exhaustive. And then if you make changes to whatever this enum type is, then you'll be forced to go reevaluate your thinking around this particular match. Whereas if you just do an if let, this is not exhaustive, and like if this data type changes in the future, it's not, the compiler's not going to force you to revisit this case. So it's a long-winded way of saying like a lot of the times I like match even though if let would work. So here we say child.kill, and this is going to return a result because the kill might not succeed. But once you're in a drop method, there's nothing to do here. So if the server doesn't die, there's nothing we can do about it. You could panic here. In fact, let's panic here. I don't expect this to ever actually happen. And this is test code, not production code. I want to say kill. That child better die. Ooh. That's going to be on YouTube forever. And I think this will type check. I'll type check it really quickly, and then I'll say a little bit about why I took that child out of the state. This looks like it's going to build. So here we could have also written I'll show you. We could have written something like, this is actually kind of ugly. I'm glad I wrote it the way I wrote it. Something like that. And then left it in place while killing the process. And the reason I generally don't like to do that is because we saw in our code for the library here, sometimes there's multiple paths to the destructor. Like in our library, we have a close method where if you want to destroy the client explicitly, you can. But this close method then becomes the destructor, and the drop just defers to the close method. And so what that means is that you have a potential recursion here where close is, taking drop or taking the client by self, and then drop still gets called down here. So in this case, in the client, the solution there was to, what was the solution here? We have to null something out, the pointer. Oh, right here. So we did a similar thing here in this close method where we took the pointer, the unsafe pointer out of the client and left a null pointer in place. And then the termination condition for that infinite recursion is whether that unsafe pointer is null or not. So I did the same thing here in our test harness, though it's not really necessary. But I kind of like that. Like this test harness begins life with an empty server, like no child running. Then it changes state over the course of its life to have a child running. And then right before it's destroyed, it changes state one more time to go back to none for the child. So I kind of like that life cycle there. Again, this is kind of a nebulous decision, but I think I like it. Sorry, this is no longer AbsRef. This is take. We're taking that child object. All right, let's see if this builds. Cannot borrow a child as mutable right here. Now we can. And let's look at what these warnings are. I'm not sure if these are all intentional or not. Yeah, okay, so we have made some mistakes here. This prepared database returns a result, so we need to handle that result. And compiler told us that exactly right here. And it told us exactly the solution we just did. And the status in the command status on line 45, I don't remember what that is. So here's another result. And this is saying, I think it's another must be used type of thing. But this is actually, no, we probably should handle this. Here we'll say assert status.success. Because this is, again, formatting the database and like, it's got to succeed or the test is going to fail. All right, that should handle all of our warnings. And let's see what our workspace looks like. Okay, that's okay. And so again, serve here. And also, we might end up just folding all of this into the constructor. So immediately when you start the test harness, it just starts serving something. I'm not sure if we want that yet or not. We'll see what happens as we write tests. But at this point, we're ready to connect to the server, except that we don't know the port number. So one other thing we probably need to do is just step back and relax for a second, because I need to chill. And give me just one brief second, chat, to blow my nose, etc. I actually need a bio break, chat. I'll be back in a minute. I'm back. I'm just taking a break here. I'm just gonna let my mind settle for a bit before we keep going. My desk here is a standing desk, and so far I have not managed to stream for more than 3 hours, and we're at 2 hours now. And sometimes it would be nice if I could lower the desk and take a seat, or maybe step back over here and just chill for a second. Although I'm very far away from the mic now. This is actually not so bad in the framing. You can just sit here. I'm just goofing around right now, Chet. Can't manhandle my mic over this far. That's actually a pretty cool frame right there. Oh, that's nice sitting down. Just one second. Whew. All right, I'm coming back to work. Okay, rule of thumb is like hands width between a stage mic and you. I like using a stage mic instead of the typical broadcast mics you see on stream, just because I love just being able to grab it and move it around. But it is fixed on my desk here, so I can't wander off back there. I could pull it out of the thing like a stage performer, like this, except that I've got all the cables tied down. But let me think here real quick. You can tell that I'm really losing steam here because I am no longer keeping my train of thought. Anyway, what we're doing now is we are working on this test harness, and we are setting up a integration test harness for the Rust client for Tiger Beetle. And it's a fairly complicated thing because you got to create a new temporary directory to hold a database, a fresh database. Then we got to run the Tiger Beetle server and then run a bunch of commands through the API, the client API against the Tiger Beetle server, then shut down the server, free resources. But a pretty typical thing to do for a custom Rust test harness. The next thing we got to do is come up with a way to create port numbers that our client can use to talk to the server. So I think coming up with unique port numbers in tests is kind of a classic problem in systems programming. You can either generate them randomly, or you can kind of generate them in a way that doesn't collide. And we do have to worry about collisions because Rust is going to run these all in parallel. So we can't be using duplicate port numbers. We also kind of need to be worried in this case about running out of memory because Tiger Beetle is a big server. And I don't think we're going to be running enough copies of Tiger Beetle against big enough databases to run out of memory. But like in production, Tiger Beetle is basically going to be using all your memory. The memory exists to serve the Tiger Beetle database. But Tiger Beetle, interesting thing about Tiger Beetle is it's designed to do all of its allocation up front. So it does know ahead of time exactly how much memory it's going to use. So there's no really risk here of Tiger Beetle kind of running out of control in a test and running out of memory. If Tiger Beetle does kind of spin out of control, it will run out of its pre-allocated memory and crash hard. But also, even though Tiger Beetle does pre-allocate all of its memory, Linux has lazy memory allocation. It doesn't actually reserve any of the memory pages you ask for until they're used. So we kind of got to be aware of, how many Tiger Beetles we're running. But again, I don't really anticipate it being a problem here. We're not going to be running a hugely parallel number of tests. All right, we got to decide what to do to get a port number, and probably going to want to record the port number here. Port numbers are, I think, U16s. And I think probably what I'm going to do is not just have the system assign a port number and try to find that port number. Like, we could be like, tell Tiger Beetle to start up, and I think we can Tiger Beetle work in a mode where the system just gives it a port number, and then we can try to maybe parse it out of Tiger Beetle's logs, but that's just more work than I want to do and pretty fiddly. So I'm going to basically pick a global port number range, and this will involve doing some mutable globals, and then start just sequentially going up that range, and like we'll maybe start at like port 40,000 or something, and then we will just hope that there is no other big networked test suite on the system that is also trying to do the same thing and chewing up a bunch of 40,000 range ports. That's what I want to try to do. It's pretty conceptually simple, though there's the risk of the port collisions. And I'll wonder if that will get through review or not. We'll see. But to do this, we're going to need a starting port number. And we need to define a static, no, not a static, a global static. And we'll call it current or next port number. And this is ostensibly a U16, but because it's a global, we're not actually going to use a U16. We're going to use some kind of special type in the standard library designed for dealing with mutable globals. Because while Rust has a syntax for creating like mutable statics, in practice, the average person should never create a mutable static in Rust because of concurrency issues. You should use some kind of wrapper type that uses interior mutability to figure that out. In fact, it might just be strictly unsound to ever actually write this. I'm not sure. Like maybe you could put in kind of atomic. Maybe that is something that is feasible to do. I'm not sure. But anyway, this is not a U16. This is something like a lazy cell of U16 or a lazy lock of U16, maybe a lazy lock. And then lazy lock is going to be implemented, initialized with a constructor that takes a closure. So the first access of this next port number will initialize it through a closure. And this will be initialized once globally, and that will handle all the concurrency issues around two threads attempting to access next port number for the first time. So this is something like this, and we'll call this const first port number is a U16, and I'm going to say 40,000. Although that is pretty close to the limit of port numbers. Let's drop it down to 20,000. And then here we initialize it to first port number. And that lazy lock syntax, and even that type, I'm not entirely sure whether that's actually the type we need here. So let's go look at the standard docs again. The mechanisms for lazily initializing globals in Rust have slowly morphed over the years. And the current recommendations are no longer what they used to be 5 years or so ago. But I think the way to do it, it didn't used to be in the standard library. There was no standard way to do a lazy global initialization. I think lazy lock is what we want. There's also something in here called, let me see. There are two types that have been added in the last few years. One is a lazy lock, and then one is a once lock. All right, these are the two things for kind of doing the lazy initial globalization. And once lock is a little lower level than lazy lock. Lazy lock, we just do this, and then there's some accessor on lazy lock. Oh, literally just dereference it. It behaves as if it's the interior type. So this looks like probably the same as we wrote, lazy lock, but we have to import it from sync. So let's just go back to code again and use std sync lazy lock. I think that's correct. In its port number, we will say, I think what we want to do, we need to increment this lock. And we kind of need to do like a, honestly, an atomic here would probably work just fine. We need to like an atomic compare and swap or a atomic increment. Let's do it this way, and then we'll do it the other way for the sake of edumacation. And to do that, I think I need to go understand exactly how the acquisition of this lock works. Let's go back to the code, or back to the docs. So here it's just being dereferenced, but I feel like there's probably a function, yeah, called get. Well, nightly only, we can't call that. Yeah, interesting. It looks like it wants us to use dereferencing syntax to get a hold of it. Well, let's try that and see if it works. Hey Filcher, I'm glad you showed up in chat and distracted me with your chat, because I'm really kind of going along slowly, and I'm happy to just chit chat anytime I can right now. I'm glad that you've been following Tiger Beetle, and I'm glad you showed up for this stream. My stream is, Tiger Beetle is a Zig program, so a lot of people come here expecting to see some Zig programming. And my stream is almost entirely Rust programming at the moment, because we're doing a Rust client implementation for Tiger Beetle. I expect that after this project is, wrapped up, I will do some Zig on stream instead of Rust. But at the moment, we're doing a lot of Rust, and if you want Zig content on Tiger Beetle's Twitch, Matt Clad streams on Thursdays, typically. I don't think he streamed today for some reason. It's been a pretty slow few weeks in Tiger Beetle land through the holidays. But again, this stream is about building the Rust client for Tiger Beetle, and we're doing the whole thing on stream. So we've done like 20 episodes so far. And they're not on YouTube yet, but we'll upload them pretty soon. It's about ready to be uploaded. So what I was thinking here, oh, you're an Ada user. That's very cool. I'm kind of jealous. Ada kind of passed me by. I wasn't ever around in the right circumstances to get into Ada, though Ada was somewhat of an influence on Rust. There was a lot of discussion about Ada. There was some discussion about Ada during Rust development. I was an early Rust developer, and we actually had some early talk with the Parasail guy, one of very prominent Ada developer. He came and gave a bunch of, discussions about System-Z programming language design issues to the Rust team. And there's a lot of, every time Rust comes up on Hacker News, not every time, but one of the common arguments around Rust is why don't you just use Ada? And Ada just kind of missed its window. It's got its niche. But as far as the zeitgeist in the last decade, Ada was not quite there. And it didn't help that Ada was not, I know you're an Ada fan, and I'm just kind of talking about why Ada is not as popular as Rust right now. But Ada is not memory safe. That was always a big thorn for Ada. They have Spark, which is memory safe, but it's a limited subset of Ada. Also, Ada is not using the C-style syntax. Yeah. Also, Ada, I know I don't mean to just be like going off on like Ada versus Rust right now, but Ada's not ever been like a truly open source project. There are open source Adas, but it's always been like kind of locked. Ada's always been locked up in the industry. And one of the things that happened over the last 30 years or so is that it just became obvious that languages are basically commodities and not businesses. Right. It used to be that you had to just be in industry and buying Ada. Like now you can do Ada and a lot more, and Ada is more accessible now, but kind of missed its window. Like it'll live for a long time because it's got its industrial niche, but as far as the Zeitkite goes, it kind of missed its window. It had a good run though. It still has a good run. Ada still exists and still very popular. Anyway, thanks for setting me off, Filcher. I've got to be very wary of just like sitting and like dishing on my opinions about other programming languages that are not Rust on stream. Like I'm a Rust expert and I'm working in a Zig company, and I do have like thoughts about Zig, but I got to be careful not to just like really start ripping into Zig at any time. There's a lot I like about Zig, but it does have its rough edges. Anyway, this thing we're doing right now, I'm just kind of poking around, just scrolling aimlessly back and forth while I chit chat. We're trying to figure out how to access this lazy lock and increment it at the same time that we get a result out of it. And some of these accessor methods on lazy lock that I want to use are actually nightly. So what I'm thinking here is that lazy lock intends you to just kind of use dereferencing to access the inside of it, which is kind of, from an API perspective, kind of awkward. Like it implements deref, for example, down here. So you can kind of treat lazy lock as if it were a referencey type of thing, which is kind of naturally integrates it with the Rust syntax. But dereferencing and referencing pointers is kind of magical under the hood. I mean, it kind of looks magical. Like it's good for cases where you need things to just coerce around seamlessly, but there's no kind of explicitness in what you're writing. Like I want to be like, I'm borrowing this lock and I'm going to write to the thing inside the lock that I'm releasing the lock, and I want to be explicit about it. But this lazy lock, all the methods that would let me do that seem to still be experimental. Anyway, let's just go poke at this lazy lock and see if we can get it to do the thing I want it to do. So we have this, the thing we're doing here is we're trying to figure out a relatively simple scheme to allocate unique port numbers for this test harness. So every time we instantiate test harness, we need a unique port number so they don't clash with each other. So what I think I want to do down here is kind of put some reference code over in the right-hand pane while we work. This is the stuff we're working with. But in test harness new, I want to say let next port number equals, and I'm going to write some like Rust referencing code and hope that it just interacts correctly with that deref trait and it all just works. I'm going to take a reference to next port number. And I think what I actually need to do is I need to dereference next port number and then mutably reference it, which, you know, again, this is kind of why I wanted just a method, because like thinking about, you know, referencing and dereferencing and what it all means is pretty tough for me. So we're going to try to take a mutable reference to the inside of this global lazy lock. And then I'm going to say port number equals next port number. I'm going to dereference this reference, next port number, and now increment port number. And again, we got to do some dereferencing. Number plus equals 1. And again, right now we're using this special global static lock type called lazy lock from the standard library to do this. but I think we could probably do this with atomics. So I'm going to get this working, and then we're going to go back and just see what it looks like to do it with atomics instead, just for fun. Again, this is test code, so it's not super critical that we write it beautifully, but I'm just kind of enjoying this exploration at the moment. And then down here we have our port number, and that is going to be just like that. And I kind of want to print this, and then we'll look at our test suite output to see what port numbers we're getting, just to see if it's working visually. And this is going to be port number. And I have very low confidence that all this code is correct. I often have no confidence that it's going to compile in Rust, but this especially, I'm doing a lot of guessing about exactly what I need to do here. And I'm going to check my test suite. So I'm running the type checker for this test specifically. So right now we're just kind of testing that we have typed all the things correctly and that all the types fit together. And then we will actually run these tests and look at the standard error output under the hood to see if it's actually incrementing port numbers the way we think. Cannot borrow data in dereference of lazy lock as mutable. Huh. Interesting. So I can't actually get that mutable reference here. Why is that? What am I missing? This is a lock, so I'm expecting it to allow me to see the inside of that port number. Maybe I need to explicitly add interior mutability here. That's probably what it wants. So, okay. This is kind of the way, in normal non-static locking situations in Rust, you kind of need to separate the concerns of mutating a thing with acquiring the lock around the thing. I think we probably need to do the same thing here. And I'll go back to the docs real quick to talk about it. So this lazy lock, it's a lock around this shared resource, and in general, shared resources are considered immutable in Rust, and you need to use what's called interior mutability, or at least commonly called interior mutability, which often means I need a special accessor method to get a mutable reference to the inside of this thing, which it can be seen from multiple threads. And probably what's going on is lazy lock is not concerned with the interior mutableness of whatever is inside the lazy lock. So we might need to add something here like lazy cell. I'm actually really not sure how we mutate this lazy lock. Chat, I am actually not sure what we're supposed to put in here. Because if it was non-static, we'd make it an arc mutex, and the mutex would give you access to the thing. Maybe the thing here, we need to add a mutex around the lazy lock, in which case the pattern for this is a lazy lock of mutex, which just feels wrong because it's like a thing called a lock with a thing called a lock. I'm actually kind of stumped here. So this type, this lazy lock type, it's relatively new to the Rust standard library. In the past, we might have used something called a lazy static or something like that, and made a lazy static of a mutex. Force mute, forces the lazy returns immutable. So there's accessor methods here that give you mutable access to the interior of the lazy lock. So this is making me think we're not supposed to be adding a second mutex inside this lock. But these are all nightly APIs. There's something I'm not understanding about the lazy lock API. And again, it only implements deref, not deref mute. So there's no kind of coercion to coerce this to something mutable. It's kind of making me think maybe this API is incomplete. And there's no examples here explaining how you mutate anything inside of this, just examples of how you get an immutable thing out of it. I'm kind of just curious to see where this goes. So I'm going to do the thing I said we were going to do, and I'm going to stuff a mutex inside of this. We'll see what happens. I'm kind of lost right now. I'm kind of surprised I'm lost right now because it's kind of a very common thing to need to do in Rust. But oftentimes what you need to do is you need to lazily initialize something and then not mutate it later. So it's probably just been a long time since I've actually done this, and I didn't use the lazy lock type. I used some other mechanism like lazy static. And you also notice from the docs there's another type here that is common called lazy cell. This is for non-parallel situations. And there's another type yet still called, we just looked at it. Let's go back to this, the sync module. Called once lock. And I don't think once lock is what we need. Yeah, once lock just provides another way to initialize a thing one time, but it's much more explicit. Let's go ahead and stuff a mutex in this lazy lock and just see what happens. And then we'll go and, I don't know, try some other techniques later. But the mutex is in std sync mutex, I think. I'll make this a lazy lock of mutex. And it feels wrong, but let's see how it goes. And so this is a mutex new. And then down here, now we can do the thing that I kind of wanted to do before, where we say next port number dot lock. And the mutexes in Rust have this poisoning feature where lock actually returns a result. And so this is a next port number is currently a result that holds the mutex, but that mutex acquisition might have failed. And we're going to say, oh, this is going to be so, if we use a mutex here in this test harness situation, it's going to be a big mess because tests can fail while holding this lock, and then these locks will be what's called poisoned in Rust. And if you have to deal with poison locks in Rust, it's a big pain in the butt. But for now, let's just get something working, and then we'll revisit that. Again, I think ultimately we can just turn this next port number into an atomic. And so this next port number, we should be able to now dereference this because this is a mutex guard, which should give us mutable access to the inside of that port number. And this all looks about right to me. Let's see if this works. Cannot borrow port number as mutable. That's just because we did not make that binding mutable. Okay, so there we go. So my understanding then is this lazy lock doesn't explicitly deal with the mutation of the thing inside it. It just gives you a way to do the first initialization of this value. And if you actually want to mutate it, you have to use a supplemental type like this mutex. And that seems inefficient because this lazy lock itself has some synchronization around it for the first initial lazy initialization. This mutex also has some synchronization. So what I'm thinking then is that these docs we looked at with all those nightly only methods around actually gaining mutable access to the interior of that lazy lock are kind of like add-on features that are kind of in the works to make this lazy lock more ergonomic and more efficient. And right now, the API as it is, you have to use a mutex to actually mutate the interior of the lazy lock. Pretty ugly. That's fine. But let's go ahead and treat it, as if we're going to use this code and just see if these port numbers are actually increasing. So again, we have one smoke test here, and I'm going to create a second test. Let's call it smoke 2, do the exact same thing. And here we've printed our port number, and I'm just going to run both of these tests and see if those port numbers actually increase. And what we're very likely to see here is that both those tests failing as they are, this lock is going to end up poisoned, and we're going to have just chaos happening in our back traces. Everything's going to panic. But let's just see what happens. I'm going to run these tests, and I'm going to say no capture. That tells the test runner that we want to actually see all the output from all the console output from the test suite. And this is, I'm not running the test. I ran check instead of run, but I want to run. Nope, I want to not run. I want to test. I'm going to run the tests. And this beautiful stuttering here says we're going to run some test, and the test we want to run is called test. So cargo test tests. And then this no capture is an argument to the test runner itself. Okay, so there's all the stuff happening on the console here. And right here you can see there's our 2 port numbers. And they both tested failed. And then let's look a little closer. So one failed with not yet implemented. And they both failed with not yet implemented. So neither of them hit like a poisoning situation where the lock was poisoned. But I bet if we had enough of these tests and they were interleaved in an unfortunate way, that we would end up seeing some kind of lock poisoning issue. And what lock poisoning is in Rust is that if a thread panics while a lock is held, that lock will be treated as toxic, and you will not be allowed to open that lock again or take that lock again without a whole bunch of extra work. So not feeling good about that lock poisoning. But anyway, this is a good checkpoint for us. Like, everything is kind of working. Our port numbers are increasing. Now I want to go back and just see if we can turn this into just an atomic U16. It's an interesting experiment for me because I haven't actually dealt with static atomics in Rust in a long time, so I'm curious to see what it looks like to make a static atomic. So instead of this, I'm going to write static, and this might be the case where you can use a mute here as a static mutable variable, but I'm not sure. Let's say next port number 2, and we're going to import ustood sync atomic, and that's probably not where atomic lives. Is that where atomic lives? Let's go to the docs. Let's just guess, and the compiler will help us figure it out. It's going to be atomic U16, and it's going to equal atomic new first port number. A lot of questions here about whether this atomic new can be evaluated in a const context or not. We'll see what the compiler says. This is kind of what I want to do. I just want to say this static starts up with some defined value, and if we use the atomic API, we can just go ahead and mutate it. And the atomics use interior mutability, so actually this does not need to be mute. And again, I'm thinking there's essentially no use case for most Rust programmers to ever write static mute. I'm guessing there are a few libraries, like some of those fundamental libraries like Lazy Cell, or maybe that lock cell, or whatever it is. Like this lazy lock may use a static mute inside of it. Anyway, I feel really like I'm fading here, but let's see if this builds. And it's looking like it's going to build. That's exciting. I guessed all the right things. And I'm going to go ahead and go back to cargo check, because this is taking a long time to build. It's interesting that it's rebuilding something that is takes a very long time to link there. Okay, no atomic in sync. And there's a module called atomic. So maybe it stood sync atomic. Stood sync atomic. Let's go to the docs, y'all. Let's go back up to sync. Just collapse all this. Module called atomic Is there really not an general atomic type in Rust? I thought there was just a generic atomic type by now. Is that really the case? There's not an atomic type? Okay, well, we're going to use an atomic U16 then. And let's look at the API around that real quick so we don't have to come back to the docs again. So we can create an atomic U16, and the new function on it takes a U16 non-atomic, and it's const, so we can use it just in the static initializer. And then we want to kind of do an increment, we want to read the value while incrementing the value, and there's almost certainly some standard method for that. We don't need to do a compare, but fetch add is the thing. So if we call fetch add and give it the value to add and tell it the ordering, that is exactly what we need. And ordering lives probably in atomic again. So ordering just tells you exactly how to compile down that atomic. So it's atomic ordering, and we're definitely going to use just sequentially consistent. And I'll talk about that a little in a second. So we're going to use atomic U16 and the fetch add method. Remember that, y'all. It would be nice for streaming if I could maybe have both these windows up at the same time on one scene. Notes for the future. So we're just going to use an atomic U16. And this next port number 2 is now an atomic U16. Remember, fetch add is our method. So it's going to duplicate this code for now. We're going to say let next port. Nope, we're going to say let port number equals next port number dot fetch add, and we're going to add 1 to it with ordering sequentially consistent. And that will do the add. And then we got I believe this atomic add is almost certainly a wrapping add. Normal math in Rust is not wrapping, but the atomic math is probably wrapping. I'll go back. Let's go back and look at the docs and prove it. Prove it to ourselves. Fetch add. Wraps around an overflow. Okay. Anytime you're doing math in Rust especially, but probably in most languages, people should be very concerned about wrapping. You really need to be concerned about the behavior at the edges of the supported number range. So what happens when you add +1 and it goes off the end? And we need to think about that a little bit here. And fetch add, the atomic add, is going to be wrapping, and we don't want that. So we're going to say assert port number not equal to 0. So if this ever wraps back around to 0, that's bad news. Shouldn't ever happen in our test suite, but bad news if it does. And the reason we use sequentially consistent here is because sequentially consistent is the strongest ordering for atomics. I'm not really equipped to talk about atomic orderings right now, but atomics are how you implement synchronization across threads in programming languages. What they translate to in machine code is very complex and dependent on different machines. But in the last decade or so, there's kind of a standard agreement on how to model atomics in programming languages. And there's all kinds of rules about what happens before and after this operation. And the before and after of atomics is determined both by what the compiler emits as machine code, but also the CPU's physical behavior at runtime, like what is allowed to be seen before this moment in time, what's allowed to be seen after this moment in time. And sequentially consistent orderings are the strongest. It just says everything before this happens before, and everything after this in the code happens after. And both from the perspective of the current thread and other threads, that causality will be maintained. So you write code up here, it looks like it happens before. Code down here looks like it happens after. So in general, as a default, sequentially consistent is the thing to use for atomics unless you're very smart and think about it very hard, because atomics are extremely error prone. So I always just use sequentially consistent unless like it comes up in code review or something that you should be more efficient here. And we need to import that ordering type. And I'm not an expert on atomics and synchronization, thread synchronization, lock-free programming, stuff like that. I've done a fair bit, but not an expert at all. Pretty mind-bending. And very hard to know that you've done it correctly. And I think this is all about right and should type check. So let's just give it a look. And what? Oh, okay. Sorry, I was looking, y'all, at the old error messages, thinking like, surely I resolved that. It says there's no method here found because I used the wrong port number. It's looking at the lazy lock, but we're doing an atomic here on port number 2. This is the next port number 2. That's our atomic port number. There we go. That compiles. So definitely atomics is the way to go in this case because it's just much simpler to write. The code just looks better. So we'll call this next port number. And this is next port number. And we can look at these port numbers one more time just to see if they're still incrementing as we think they should. And you can see right there, there's our 2 ports for our 2 tests. So this is all looking correct. And I really want to make sure there's no... I still haven't done everything correctly here because I got a lot of warnings. We're not using lazy lock and mutex. And chat, I just noticed that I left the background music just plodding away. I'm glad that hasn't annoyed anybody yet, but I should be able to shut that off. Sorry about that, y'all. Let me look at my audio setup real quick. There we go. Oh, suddenly so much quieter in here. All right, let's go get rid of that lazy lock and that mutex and think through what we were doing with our port numbers here. Okay, I think we're good now. Let's go run cargo check. I think we handled that. Port number is not used, really? Oh, right. We're assigning the port number, but we still haven't written the code to launch the server with that port number. Okay, so down here when we say serve, we haven't actually written the code to serve the database at all yet. So, all right. Next, thanks for the feedback, Filcher. Yeah, originally my idea was to just kind of like always have some background music going on and integrate more music into this programming stream, but so far it hasn't really panned out that way. And I did get some feedback that the music was kind of distracting, which is fine. Live and learn. All right, so we aren't actually serving anything here. So I'm going to put some reference code on the right-hand side of the screen for how to launch one of these commands, because again, I'm always forgetting this exact command API. And we need to create a new command for starting the server. So the command is going to be, I'm literally just going to copy this code. And we're not going to use status down here. So we're going to launch the Tiger Beetle bin again in our temporary directory. But instead of format, we're going to say start. Replica count we don't need. I think we need a replica. Let's go to the command line and ask the command line what we need to do here. So we're going to say build run start. And just have the Tiger Beetle CLI tell us what arguments we need to pass to the server. I think, again, I'm just kind of brain dead while it's compiling. So we need addresses. This is the thing that's going to have to take the port number. but here we're going to say 127.0.0.1, 20,000. And we also have to pass the path to the database. And that's it. Okay, that's easy. So in our code, we say yeah, the Tiger Beetle is it's a distributed database, and there's one command for managing the server and also connecting through a REPL. So the Tiger Beetle command has a REPL as well. And occasionally on this stream, we use the REPL to kind of understand the behavior of the server and its protocol. So it's going to be address is equals 127.0.0.1, and then we need to splat a port number in here. And that is self.port number. Seems about right. But then instead of, the server needs to be mutable, because remember from like 2 hours ago, when we designed this API, we're going to just store the child process right inside of the test harness object. So we need to mutate the test harness object. I'm going to say child equals command.args, command.spawn, I think. And that gives us a result of a child handle. And this could fail. And then we just store that child handle in an option. And probably we should also assert that we have not already run a server. Self.child, oh, not called child, it's called server here, which I do like better. I'm going to assert that we don't already have one. This all seems about correct. Then let's go ahead to our test case, and we're already calling serve, and we don't need 2 test cases anymore. Oops, where did that come from? All right, let's see if this checks first. And then we will try to run it. And again, we have this moment of no momentum while we are linking something here. I'm curious what this link step is right here, because I don't need to be linking a binary to run these tests. It's probably linking our test binary, or our smoke test binary from earlier. Okay, so I didn't get everything correct here. This harness needs to be mutable now. And oh, I thought I deleted uSmoke2, because our serve method is mutable, so the harness needs to be mutable. Okay, so that checks. Now, does it test? I still think this test is explicitly going to fail. But if we remove this to do, this should run the server, and this should destroy the server, shut down the server. This should, the whole server life cycle should be here now. Really quick, I'm curious what's in our work directory. Remember, our work directory contains our temporary directories, and there was some old temporary directory. This is probably the one we looked at explicitly earlier. But essentially, this work directory, when the test suite is not running, should always be empty, because those test harnesses will delete the server, shut down the server, delete the tempter. So really quick, I'm going to run this test one more time. We're not panicking here anymore, so this has to return a result. And now I'm expecting that it's going to pass. And if we look at that work directory, so I was expecting there not to be anything in this directory, and I was wrong about that. That is curious. And I'm thinking about why that could be. So why is that? Right now I'm thinking is drop order. There might be a drop order incorrect here, because we're depending on the test harness's destructor to do several things here. Yeah, several things here. So there's two resources being held by the test harness. One of them is the temporary directory, and one of them is the server. This server is holding on to a child process that has a file open inside this temp directory. And what I suspect is happening here is that the drop order for structs and rust is forward. So this will be destroyed, this will be destroyed, this will be destroyed, this will be destroyed. And if the server is destroyed last, the temp dir can't actually free itself. But even as I say that, I'm going to leave that struct over here on the right-hand side. On the left-hand side, in our drop, we did explicitly pull this server out and kill it. So the drop order, we're changing the drop order here. When we destroy test harness, the first thing we're going to do is kill this server. But for some reason, like maybe we need to kill the server and then wait for it. But it sure seems like by the time this temp dir is being dropped, the server has not freed up its handle to the database. That's what I would guess is happening here because our database still exists there. So let's go look at, like maybe this kill just sends the signal and doesn't wait. So maybe we need to kill, then wait on the process. That's my intuition. So let's go read the docs and see what it says about kill. So again, we're going to go back to std.rs, command, and there's a kill function here. Nope, it's not in the command, it's in child. So you spawn a child, you get a handle to the project, to the child process. And then let's look at these English docs. Call wait to wait for it. Nothing about kill up here, but here we say forces the process to exit. This does not say anything about whether it waits for the process. But what I'm guessing is that the mappings to error kinds equivalent to sending a sig kill. So I'm guessing this is not a kill, wait for exit. This is probably kill, then you got to wait for it. So let's go try to do that. Say child.wait. And wait returns an exit status. And there's no result here there's no way to handle errors here in drop. You just got to deal with it. I would expect that wait will never fail here. That would be a strange thing to see in our test suite. So I'm just going to say wait has to succeed. And then this is going to return a status, and I don't think we care about it here. We could check whether the server exited with a 0 exit code, but doesn't, filter. So we did like this kill is brutal on the server, right? This is like not the correct way to shut down most software because it's just going to, the operating system is going to forcibly shut down Tiger Beetle. Like there's nicer ways to do it in most cases. Like you're saying sig hup is kind of like the defined way to tell a server, I would like you to shut down right now, server. But also Tiger Beetle is very explicitly designed to handle just catastrophic destruction of the entire world around it. So if Tiger Beetle just suddenly stops working, it is supposed to come back up just fine. So I don't really mind using kill for this. But you're right. Most software you would not want to just send a kill. You'd want to send something like sig hup, usually sig hup. But conveniently, we have a kill method on our child process handler. So kill is what we're using. So this, I suspect this is the thing. This is going to get rid of a race condition and make these work directories, temporary directories, disappear. Let's try to run that test again and see if that is the case. Still works. then in our work directory is nothing. So that intuition was right about what was going on there. It's an interesting case because like when I saw that behavior of that temporary directory just still being around when it shouldn't, like I just kind of immediately guessed what the issue was, because that's the kind of thing you see a lot, decades of this kind of programming. But that'd be pretty hard for like a new programmer to guess what is going on there. But that's the nature of concurrency. So we're in a pretty good spot here. The test harness, I think, is finally working. So that took us over 2 hours. And now we can finally start testing the client against the test harness. And I'm thinking maybe I might be pretty toast here. It's been about 3 hours. I don't know if I'm going to have the brain power to keep actually writing the tests, but this is pretty good progress for today. All right, I'm just going to take a real sip and just think real quick about whether this is a good stopping point, but I think we're going to wrap it up here, chat. All right, so the server is creating a fresh database and serving the database on a unique port, and we have the port number available in the test harness type. So all we have to do here, I think, is just start using our API to talk to this server, and we should be good to go. Okay, so we're going to wrap it up. Today we stepped back a little and fixed a problem with our build script that we introduced yesterday or in the previous stream. So now we have it set up so that when we build the Rust client crate for Tiger Beetle, if that crate sees that it is in the Tiger Beetle code base and not deployed to crates.io, it will kind of reach up the directory tree, run the Tiger Beetle build to make sure the TB client static library is in place and ready to go, and then it will link against it. So where for several months we manually ran the Tiger Beetle build before running the Rust build, now we don't have to do that anymore. Every time we run the Rust build, we will get the Tiger Beetle build, and it's all wired up correctly so the dependencies will trigger rebuilds of the Zig code. That's very nice. And a very good example of practical Rust programming. That is the kind of task that is pretty common in Rust and a little bit fiddly, a lot of little details in it to get right. And now today we also built a custom test harness for doing integration tests against the Tiger Beetle server. So we can create directories to hold our database, launch the Tiger Beetle server against those, build the database, reformat a fresh database in a temporary directory, and run the Tiger Beetle server against that database, and then it all shuts down again, deletes the database, deletes the temporary directory. So that's kind of like the scaffolding we need to actually write tests for our crate. And so probably the next stream we will write some tests. I don't think we're going to go comprehensively write a bunch of tests. I just want to basically make sure that we have enough functionality, we have some confidence that the crate works as we think it should. And then we can kind of get an initial PR in and get it reviewed. And then in the future, we'll come back and really lock everything down, make sure everything behaves the way we expect it to in various corner cases, and write some really nice docs. And we should be really flying soon. There's a question in chat about Neon Postgres. And Filter, I have not heard of Neon Postgres. And even though I'm in the database industry and I have worked multiple jobs in the database industry, I'm not really a database expert. I'm not at all a database expert. And there are so many databases always coming out that I don't really keep up. But for the purposes of the stream, Filter says that Neon Postgres is in a similar zone as Tiger Beetle, and it's worth looking into. And I will at least go give it a Google after this and read what Neon Postgres is all about. Thank you for bringing that to my attention. So again, my name is Brian Burson, BRSON on GitHub. My socials are available on my GitHub pages, burson.github.io. I'm doing this entire project on stream on Twitch and will eventually upload a playlist to YouTube. I don't have a schedule, but I usually announce it on the Tiger Beetle Slack 10 minutes ahead of time, as well as my Mastodon account. I really appreciate everybody showing up for chat today and helping me out and giving me feedback on stream. That really means a lot to me, and it does help what I'm doing here. Thank you so much. I will see you next time.